30 centimeters long. So that's the length, the whole thing that we're using to form this rectangle. So the rectangle, you know how rectangles are formed. Two sides,
Yes.
these opposite sides are equal, right?
Yes.
Then they are saying, if one of its sides is x centimeters, express the area as a function of x alone. So we don't care the one that you call x, but if you call this guy x, even this guy will be x. We don't care what you call this to be. So let's call this b. You know to say the area here is going to be bx, isn't it?
Yes.
And you also know to say the perimeter here is going to be 2, you know it's x plus b. Then this whole thing was given to be 30. The perimeter, the length of the wire that we used was 30. So you're okay with this, right?
Yes, that's why I ended in knowing the formulas. And I moved to the next part.
Okay, so now there is no way that you can move to the next part without making x the subject here, because x plus b is going to give you 15, right?
Yes.
You got this part. Then from here you make b to be the subject, because they want the area to be in terms of x. So meaning we make b to be the subject. So b is the same as 15 minus x. So now in the area, wherever there is b, we'll put 15 minus x. Then we have an x this side. So the area is simply going to be 15x then minus x squared. That was the answer for the first one.
Oh. Okay.
So once you get this guy, this is now a quadratic. Now they want you to complete the square. Once you are done completing the square, that's when you will get the minimum. Is it? They say the minimum or maximum, right? Because it's going to look like this. Because the coefficient of x squared is negative. So yeah, when you're done solving this, not sure what you got, but I think we should get, let's try to do it here together. This I think would give you negative. This will be x minus, this is 15 over 2, then squared minus 15 over 2 squared. Then this is going to be a negative x minus 15 over 2 squared plus 15 squared, so you have your 15 squared here over your 4. So this giving you your turning point to be, there is 15 over 2 and there is a 15 squared over 4. So the value they wanted here, the maximum area was this. This is the maximum area you can possibly have. The value of x, this guy here is the x, because when you solve this part inside, equate it to 0. So x is equal to 7.5. Then now you can get the other guy, because you notice that x and b, they're going to be the same. Yeah, because 15 minus 7.5 is still going to be 7.5. So you notice 7.5 plus 7.5 is 15, but the maximum is when you multiply them, which is 7.5 times 7.5. So you are saying that you tried all numbers. So look at this. So you know you got at 15. Then you tried 3 by what? What numbers were you using? You can try. Hope you tried.
I did 3 by 12. I did 10 by 5. I did 8 and 7.
So the summation is 15. So you say you tried 3 by 12, right?
Well,
you notice this is a 50. This guy here gives you what? 36, right? Then what other combination can we try? 15 by 1 is you 15.
9 and 6. Or
9 and 6. It gives you what?
Yes. I should give 54.
54. 54. Okay, 7.5. Yeah, so you're getting a 54, something like
also
that.
Also tried 7 and 8. That was the highest one.
7 times 8 gives you what?
56.
56. Now look at 7.5 times 7.5. It gives you 56.25.
Oh.
Yeah. You've seen that, right?
Yes.
Okay, so you want us to specifically start on question number 17.
But can you please show me how you are solving again? I want to finish writing it down.
Oh, okay.
Okay. Wait, I have a question. Since you said that the maximum turning point is the 15 squared over 4, right?
Yes.
Then 15 squared 225. So 225 divided by 4 will give us 7.5.
You're saying 15 squared?
I've seen that 15 squared
Uh-huh.
divided by 4 gave us 56.25, the same maximum turning points.
Yes, it
I've
gives
now
you...
seen what you've done.
Okay, it gives you the area here, right? Yeah.
Yes. But would I get at least marks for trying, or it will just be as no?
You get a half mark. Yes. But the rest were just okay?
Yes, okay. I really like the last question since we went through it together. Then the rest were I could answer them.
Oh, okay.
Yes.
Okay. So we can start at question 17 now?
Yes, we can.
Okay, so question 17, they're saying the functions s and t are defined by these equations given here, and you have t this side. For all x, which is any real number, that's what we're having, where b is constant, the equation s of x is equal to t of x has exactly one root. So if it has one root, it simply means the discriminant is equal to 0, right?
Yes.
They're saying when we equate s of x and t of x, when we solve it, when we equate them and try to solve it, we should just expect to get one value of x. So they want us to find the value of b because we don't know what b is from t of x. So we're going to say, this is question 17. So s of x is equal to t of x. So s of x is negative 10. So negative 10 minus x. Then this side, we're having a 2. So there's a 2 modulus of x plus b. Then there is a minus 8. This is what you're having this side. So you equate them like this. Then now we try to bring the 8 on the other side. This is going to give us negative 2 minus x is equal to 2. Then this is what you have. You're okay up to this point, right?
Yes, I'm okay up to this point.
Okay, so from here now, the way we get rid of the square, this guy here, is by, the modulus, is by squaring both sides, because what the modulus does, the square does, the only difference is that the square, first of all, expands it. For example, negative 2, if you do modulus of negative 2, you get a 2. But if you try to square this, so we're just going to square negative 2, it does the same thing, except it makes it twice as large. Yeah, but it makes it positive. But if you are trying to get rid of the modulus expression in this case, what you do on the left-hand side, you also do on the right-hand side. Yeah, so here we can expand this. This is going to give us a 4. Then this is going to be a plus 4x. Then this is plus x squared. This side will give you a 4. Then we expand this. You get x squared plus 2bx, then plus b squared. So I've just expanded both sides. Is it okay?
Yes, so I think we do the same thing we do if it was given, like maybe we are doing that, we put that thing for finding the square roots.
Yes, exactly, yes.
Okay.
So now from here we just expand and then try to solve this to gather the like terms. 4x plus x squared. This is equal to 4x squared. 8bx, then this is plus 4b squared. Then from here, when we gather the like terms, we're simply going to get, I'll take everything on the left, this side, I'll take them on the other side. So it's going to be 3x squared because of this subtracting with that. Then when I take this on the other side, it will be 8bx, then minus 4x. Then there's going to be a plus 4b squared minus a 4. This is going to be equated to 0. Then from here...
We did plus 4.
Which part?
The last part where you said minus 4. Shouldn't it be plus 4 since in the first part there it was taking it to the other side?
This guy here, let me just change the color. You're talking about this one here?
Yes, shouldn't it be plus 4? here.
Or we are crossing it on the other side, so it
Oh,
becomes
to the other side.
Yeah.
Okay.
Yeah, that's what we have. Yeah, so they're saying the discriminant is equal to 0. So meaning the a in this case is the coefficient of x squared, which is your 3. Your b, in this case, your b is going to be 8b minus 4, right?
Yes.
Then your c is 4b squared minus 4. That's what you have. Now, they're telling us to say the discriminant is equal to a 0. So b is this. So we put our 8b minus 4. We square it, minus 4. Your a is 3. Then your c is 4b squared, then minus a 4, and equate this to 0. Then this is just going to be, when you square this is going to be a 64, sorry. This is going to be, we're looking for b, so this is going to be a 64 b squared. Then 4 by 8 is what?
32.
32 by 2, that's going to give us a 64, so this is a negative 64b here, then plus 16, then this is a 12, so 12 times 4, that's going to give us what? Negative 48, right?
Yes.
Then 12 times 4, I mean, again, it's the same thing, right? It's 48.
It will be plus 48 since it's negative 12.
Yeah, this is equal to 0. Then from here, we can try to gather the like terms. There's a 64 here, there's a 48. So 64 minus 48.
It will be 12b squared.
12, it will be 12b squared.
Yes.
So 12b squared.
But
then,
let me do it again first. Maybe I'm going to find.
Okay.
0 minus 48. Oh no, it's 16b squared. 16.
16.
Yes.
Also, this is going to be a 16. Then this, how about the part for the b? This is going to be, it's just negative 64b.
Yes.
Then 16 plus 48, that's going to be 64.
Yes.
Then we can divide throughout by 16. 16 there, that's going to give us what? 16 into 64.
That will give us 4.
It will give us a 4, so this is going to be 4b. Then even here 4 is equal to 0. Then from here, we can actually try to complete the square here. It's going to be like this. Then minus 4, this is plus 4. This actually makes sense because now, when you solve this, this is going to be 0, meaning b is equal to 2. When we solve it using completed square method.
Yes.
Is this okay, Madam Yumezi? Or it's confusing?
Yes, it's okay. It's like that question in literacy. She was it number what was it, number 10? Was it number 10? Or number what was it? I think it was number 10.
Oh yeah, it's almost the same, yes. Yeah, so from here we can go to 18, right?
Yes, we can go to 18.
So 18, they are all moduluses. These are now equations, so meaning we are solving. The good part is that when you're done solving this, you always have to test your answers that you'll be getting. Yeah. So, like for the first case, they are telling us to say, this is 3x plus 4. Then they are equating it to 8. So we're having, this is question 18a. So it's the same thing that I said. This is going to be that. You square both sides. You just say 3x. I'll show you method 1. Yeah, so method 1 is why you square both sides. It's the easiest.
I was about to ask you a different method. What's that method for? You put in the negative in front?
Yes, yeah, that's there. You redefine it. It's called redefining it.
That's a hard method because it really confuses me.
Yeah, that's a longer method, yes.
But it gives the same answer.
Yes, it's supposed to give us same answers. Yeah.
Okay.
Yeah, but this one is always straightforward, and you only use or opt for that one if you have a bigger expression. Let's say if the guy inside here was a quadratic, because because imagine expanding a quadratic equation inside here, it becomes a polynomial. So you avoid that by just redefining it.
Okay. Okay.
Yeah, so this is 9x squared then plus 24. X minus 48 is equal to 0. Then 3 can divide these, right? 3 can go everywhere here, right?
Yes, it can.
Yeah. 3 there, that's going to give us 8. Then 3 there, that's going to give us 1. That's 16. Then from here, you know to say the product is what? The product is negative 48. Then the sum is 8. So what will be our factors? 12 minus 4, is it?
Huh?
12 and negative 4, right?
Yes.
Yeah, so this is now going to be 3x squared minus 4x, then plus 12x, then minus 16 is equal to 0. Then this is going to be x, then you have 3x minus 4, then plus here, we're going to have what's common there is simply a 4. 4 can divide them. This is going to be 3x, then minus 4. This is equal to 0. So we are getting x plus 4 and 3x minus 4. X is equal to negative 4, and also x is equal to 4 over 3. So once you get your two answers, you don't accept them as your final solutions. You have to test them back in the original expression. So the expression was saying when we put something here, we should always be getting 8. Yeah, so we're just testing. If we put negative 4 here, that's going to give us, so the left-hand side, 3 and negative 4, then plus 4. This will give us negative 12, then plus 4. This is going to be negative 8. This is 8, right?
Yes.
Then again, if we try this one, so we're saying 3, we put 4 over 3, then plus 4. Okay, this works again. The 3 and the 3 goes. This will be 4 plus 4, that's 8. Okay, so they both work, so we take them to be solutions.
Can we now try the second method?
Okay, so the second method on this same guy, on this same, we're saying we have 3x, then plus 4. Then we're saying, we redefine this part first. We're going to say this is going to be 3x plus 4 if 3x plus 4 is greater than 0, or negative 3x plus 4 if 3x plus 4 is less than 0. So we take each of these pieces. There is 3x plus 4 equated to 8. So this is going to give us 3x is equal to 8 minus 4. 3x is equal to 4. Then we divide. So x is equal to 4 over 3. Then we take the negative one as well. We're saying negative 3x plus 4 can also be equal to 8. So I can simply take 3x plus 4 is equal to negative 8. This is 3x is equal to... Did I do it right? Okay.
How come we move the negative to the 8 now?
Oh, because it will be... let's see. Okay. Because I divided both sides with a negative, so it simply... I divided by so that now it becomes negative like that. So now it's going to be a negative 12. Is it? Then we're saying we have a 3, x is equal to negative 4. You notice that the same answers, right?
Yes.
Yeah, so this is the other method that you can use as well.
I think method 1 is simpler.
It's simpler, right?
Yes. Now as we learned method 2.
Oh. And then you are finding it challenging?
Yes, because again then she was drawing graphs, and then I didn't understand why we were trying to draw graphs afterwards.
Oh, because the drawing of the graphs is important for questions like the second one here, because you have to test. That's a badness about method 2, because it takes long. You have to be, confirming this and stuff. You have to verify the domains, because each piece that you define for x plus 6, it will not accommodate this guy. You have to be looking for pieces where they have an intersection before you equate them to each other.
So, but I can use the first method for the second one.
Yes, you can use. That's even advisable when you have square root. I mean, when you have modulus on both sides, we opt for method 1. So this one, you were right. Here you needed to use method 2. Here you need to use method 1. Here we needed to use method 2 because there's only modulus on one side. Then here, method, we can use method 1 because it's easy. Yeah, or you can use method 2 here, MAT2, because modulus is just on one side, right?
Yes.
Yeah, so it depends really what you decide to use. Yeah, they will never specify in a question. They'll just say solve. So it's up to you because you still score the same marks. Yeah.
How come sometimes, like when you're doing like the quizzes, the tutorial sheets are simpler than the quizzes, like some questions in the quizzes where I just therefore I've seen this somewhere, but wouldn't phrase like this.
Oh, trying by all means to bring tricky questions on the same topic because they know that people obviously have done the topic, have completed the topic. They just want to check how deep you went in the topic in terms of understanding the concepts.
Because I was really shocked on Sunday, like at 14, I was doing the chemistry quiz, just therefore, why is this way harder than the chemistry test 1?
Oh. Oh yeah, but you see your test. When you start writing your test, you'll see it. It's actually going to be fair.
Okay, but when will we get our results? Because we've had quizzes, but we haven't seen any of our results at all.
No, they should be published before. They should give you your scripts back before your test, before you write your test. So expect them before mid-May. They should give you, I think they're done entering or something.
Oh, okay.
Yeah. Because initially they were supposed to give you just before you wrote your quiz 2, you needed to know how you performed in quiz 1 because that's why you know either you have to pull up your tokens or you have to know the effort you need to put in here. But I think they were overwhelmed. So yeah, with the way they were because your intake, you guys are a lot.
Oh.
Yeah. Then question 18, this part here, how about this part here?
This is the part for where you square one side and you square the other side, right?
Yes, you square one side and then, yeah.
Can we try number 9 and number 10 and number 8?
Number 9, you mean this one here?
No, I meant number 10.
Or number 10, this one?
Yes, number 8.
Number 8, okay.
And number 5.
And number 5, this guy here, okay.
Yes.
Okay, so let me start with number 5. So they're saying 5 over x plus 4.
Coming. Hi. Hello.
Minus 4 over x.
I trained it with the first one with 5 over x plus 4.
Oh, this is a 4? Okay, let me...
Yes.
Okay, so for this case, it's very straightforward. You just solve the left-hand side, make it into one expression. It's going to be x plus 4. Then you're also going to have x this side. Then here, you can have 5x, then minus 4, x plus 4. Then this is equal to 21. Then you have 5x plus 20. Then here, you're going to get your 5x, then minus 4x, then minus 16. Then this now is going to be x squared, then a plus 4x is equal to 21. Then 5x plus 20. Yeah, then this you cross multiply. You are simply going to get, so before I go anywhere, are you able to see here? Let me try to show you something here. You see that down here there was x plus 4. And this side, this is 5x plus 20. We could have written it like this. 5x plus 20, you could have written it as x plus 4. It's the same as this. You see that, right?
Yes.
So now, if you have something similar on both sides, so we'll cancel this. So this is already a non-factor, so we'll keep it aside to say we cancelled it. Then we are going to have 5x minus, the top guy can actually be, because they are like terms, so we can say 5x minus 4x, that's x, right? Are you okay with this?
Wait, where did we remove 5?
Because here 5x minus 4x.
Okay.
Yeah. And then from here now we cross multiply. This is just going to give us a 5x, then minus an 80 is equal to 21x. Then this is going to give us negative 80 is equal to 21x minus 5x. This will be negative 80 is equal to, this is going to be what? Is it a 16? 16x. We have 16. So this is going to give us x is equal to negative 5. Now we already have another answer here, which is x plus 4. The guy that we cancelled, this is negative 4. So this was also part of the answers. So now this one here, there is no testing because it was what? They said be sure to check answers and recognize any extraneous solutions. So we are supposed to check whether the left-hand side is going to be equal to the right-hand side when we replace with the values of x. So we found the first one to be x is equal to negative 4. So we can just replace here where there's, you are seeing here it will fail already because you see that 5 over negative 4 plus 4. The down part becomes 0. In short, it's not part of the domain. So this whole thing here cannot work when you have a negative 4. Same applies even here. Put negative 4 here. Negative 4 will be 20. Negative 20 plus 20, that's a 0. So already it's failing. So negative 4 is an extra solution, but it's not part of the actual solutions that can make the left and the right to be the same. So that's what they're calling extraneous solution. Then we try the other guy, which is a negative 5. If we try negative 5, it should work out. This will be, the left will be 5. Then negative 5 plus 1, that's negative 1. Then minus, this is 4 over negative 5. This is going to give us a negative 5 plus 4 over 5. So this, we can simply say that we simply have a negative 25. This will be negative 21 over what? Over 5. That's what you get. Then the right hand side, there's a 21 on top. Down, we put negative 5 here. Negative 5 times 5, that's a negative 25. Plus 20, that will be a negative what? That will be a negative 5. So you notice the answers are the same, right?
Yes.
Yeah, so the correct solution is negative 5. Negative 4 was an extra solution. So that's what you do there for number 5.
Okay. I was wondering since they don't have any modulus or square root, so I was scared for how are we supposed to solve this? But now that you solve this one, I think maybe I can try the others on my own.
So like this one here, you just square both sides, right? Square this side, equate it to the square of this side. That's square both sides, and that's all.
Then for number 9, I just square everything.
Yes, square everything. So it's going to be x plus 1. Square it on top. Then again you have x minus 1. Square it. And also have your 3 this side, square it.
Yes.
The only thing that will be interesting is this guy here, because this will turn to be a polynomial with x to the power 4 when you are done. So you have to solve it. The normal way we solve a polynomial, x to the power 4, trial and error method, you break it down, synthetic long division. That's what you do. When you add
do number 10 looked hard.
Okay, so we can do number 10, right?
Yes.
So there is a 6, x squared plus 1 is equal to 1 over x squared, then plus 10 x squared plus 4, then this is 6, you have x squared plus 1, this is equal to x squared, then you have x squared plus 4, then this will be x squared plus 4, then to be 10 x to the power 2, then this will be 6 plus 1, this will be 11 x squared, then plus a 4, then down, if you multiply this, you will get x to the power 4 plus 4x to the power 2. Then here we can cross multiply. When you cross multiply, you're going to get x plus 1 to the power 1, then 11x squared plus 4. Then this side you just get 6x to the power 4 plus 24x to the power 2. Then this is going to be 11x to the power 4, then plus 4x squared plus 11x squared plus 4 is equal to 6x to the power 4 plus 24x squared. Then this will now be, or when we take the 6 on the other side, so that's going to be a 5. This is 5x to the power 4. Then we are having what? We are having, this is a 15 here, right? 15 minus 24, that's going to give us negative 9x to the power 2. Is this okay?
Yes, it is okay.
We took the 24 on the other side. Then we're having a what? A plus 4. So this is going to be like this. Then we look at the constant, trial and error. We can put a 1 there. 1, yes, 1 will give us a 0. So x is equal to 1 works, meaning x minus 1 is a factor. So now I'm using synthetic to break this guy down. There's 5, there's 0, there's negative 9, then there's 0, then there's a 4 at the end. I bring down the 5. This will be a 5 here. This is a 1, by the way. This is a 1. Yeah, so this is a 5. This is a 5, negative 4, negative 4, negative 4. This is negative 4. That's a 0. So the quotient we're getting will be to the power 3. This will be now to the power 3 for x. This is now minus 4. Again, you break this one down. Yeah, in a similar way. So and so on until you get your 4 answers. There will be 4 of them. Yeah, those will be your answers. Then you test them to check if your right is going to be equal to the left. So from here, again, if we try to break this guy down, we look at the last number. 1 will fail. When you try x is equal to 1, it's going to fail because you have 5 plus 5, that's 10 minus 8, that's a 2. So we try negative 1, this has failed. We try negative 1, this will be negative 5, then plus 5. And this is going to be, no, this is going to fail as well. Yeah, because this is going to be what? This is okay. Oh, this works actually. This works.
Oh, it is.
Yeah, it works. So meaning x plus 1 also works on this guy. So we try negative 1 on this side. We have a 5. We have a 5. Negative 4. Negative 4. We bring the 5 here. Negative 5. That's going to be a 0. That's going to be a 0. That's a negative 4. That's a 4. This is a 0. So the quotient, the other quotient is 5x squared minus 4. So we have this, then we had x plus 1, then we had the other one which was x minus 1. So you have your first two answers. Solve this, it will give you x is equal to plus or minus the square root of what? Of 4 over 5, right?
Yeah.
Yeah, so these are the answers that you have. Then you test them by putting them back in the expression to see which one is going to work out. Yeah, so these ones
Now,
here.
how do you test the one for the square root?
So this is the same as 2 over root of 5, right?
Yes.
So if I want to test it in the expression, this expression, I'll start with, I'll just test the positive one. Yeah, so here we're just saying the left, if you say 6 over, here I'm putting 2 over root of 5, then the square, then plus what? Plus 1. This is going to be 6. This is 4 over 5, then plus a 1. Yeah, so you can just add, this is going to be what? 6 over, is it a 9 over 5? When we flip this, this is going to be what? A 30, is it? A 30 over 9, I think. Yeah, then this guy again, we do the same. You can test, you put 1 over 2 over the square root of 5. This is squared, so meaning the square root will cancel. Then plus 10 as well. This again, the same thing, 2 over root of 5 squared plus 4. Yeah, so this is now going to give us 1 over a 4 over 5, then plus 10. This is a 4 over 5 plus 4. This can be a 5 over 4 plus 10. Then down here you're just having what? This is a 5, what's going to be? This is going to be a 24 over 5, which is the same as 5 over 9. I mean 5 over 4 this side. So the squares that you have are cancelling the square root. Yeah, this is going to be 50 over 24. Then 2 there is 25. 2 there is 12. So now we're adding this. So the common denominator is 12. So you have 12. 4 there is simply 3. 3 times that, that's 15. Then plus, this is just going to be a 25. So you have 25 by this. This is going to be 30, 40. That's 40 over 12. You can do your what? You can do your 2 there. 2 there is 20. Your 2 there is simply 6. Yeah, then your what? Is it your 2 there should be what? Your 2 there should be 10. Your 2 there will be 3. This is what you get. So you notice the left and the right, I think they're not the same. So yeah, is it? Here we're getting, did I do this right? 5, this is going to be 9. So 6 divided by a 9 over 5. This is 6 times 5 over 9. 3 there. 3 there is 2. 3 there is 3. Okay. 2 times 5, that's 10, right?
Yes.
So the answer here was supposed, oh, even here, 3 there is 10. 3 there is 3, right?
Yes.
Yeah, so the answer here is actually the same. So you notice that the root of what? The 2 over root of 5 is actually a solution. So you have to test. You can't just guess to say because it looks weird, then it's not an answer. You have to check, yeah? Is this okay?
Yes, it is okay.
Yeah, so that's practically what you do on number 18. Yeah, so the good part about math is that the skills that you learned from tutorial sheet 1 to tutorial sheet 3, some of them will be needed here. Like completing square, the reason why you learned that is because at least now you know to say there's just there's no single way of solving a quadratic. The easiest way, you can also use completing square if you want. So you need to apply the previous skills as well. They can work.
Yes.
Yeah, then how about this one? Okay, have you tried this one before? So this one is going to be very interesting. You have the root of x minus 6. The root of x is equal to 1. The easiest way you can do here is multiplying everything by the root of x. This is going to turn out to be x, then minus 6, then is equal to the root of x. Have you seen what has happened?
Yes.
So if this is what has happened, then to get rid of the square root on the other side, we can now we can square both sides, right?
Yes.
So now if we square both sides, you notice this side will be squared. The other side, we square it, the square root, and this goes. This will be x squared minus 12x plus 36 is equal to x. Then you solve this. This is now something you're familiar with. It's a quadratic. You solve it. Yeah, you get your 2 answers of x.
Okay. But yes, I can solve this one.
Okay. So the last one is question number 19, right? Let's just wrap up on 19. We do it as well. So 19 is almost the same like the previous one, except here there's an inequality. You see this, right?
Yes.
So they'll be solved in a similar way. You change the inequality, you change it into, so this is only applicable for questions like these ones here. Like this one with a modulus, this one, this guy with a modulus. You change the whole thing. For questions like this that don't have a modulus, like let me show you, let me start with number 1 first, because number 1 will also answer number 3. So when it's a quadratic, let's see the question. They're saying what? Find the values of x that satisfy the following inequalities. So we're having 3x squared minus 4. Then this is less than 4x. So this is going to be 3x squared, then minus 4x, then minus 4. This is less than what? 0. Then from here, we just try to solve this. The product there is simply negative 12. The sum is negative 4.
We don't use the b squared method here.
The what?
The b squared minus 4ac, we don't use it.
Oh no, we don't use it here. Here here they have not mentioned anything about the roots. They've only told us to solve where x should be, yeah, where this whole thing is allowed. Yeah, so that's what we're trying to do here. So now what factors can we use here?
Factors. I'm going to use we can use 6 and 2, like negative 6 and 2.
So if we do that, we're going to have 3x, x minus 2, then plus here, this is going to be what, 2, then this is x minus 2, right? Then
Yes.
this is going to be 3x plus 2, then this is going to be x minus 2, right?
Yes.
Then this here, we can check, we have to test. When you solve this, you get negative 2 over 3. Then when you solve this, you get a 2. So we put them like that. Then we put our two factors like this. Then we just test, choose any number that's below this. So I'll use, let's say, negative 2. If I use negative 2 there, that's going to be negative 6. Negative 6 plus that, that's going to be negative. I use that, that's going to be negative. I choose a 0 there. That's going to be positive. Then that's going to be negative. I choose any number after 2, let's say 5. This will be positive, this will be positive. So the overall sign here will be positive, here it will be negative, here it will be positive. Then they want where it's less than 0, meaning it's here on the middle. And they said less than, strictly less than, so x must belong in from 2 to 3, 2 over 3 to simply 2. It's open on both ends because they used less than, meaning they are not part of the set. This is basically what you have. You see that, right? Is this okay?
Yes, it is okay.
So this is how the same way that we've done for this guy, it's the same way that you do for this, except here you are even at liberty to reduce it first. This is going to be the same as x squared plus 4x. Then there's a 60 there. Take the 60 this side and solve it in a similar way. You've seen that, right?
Yeah.
So it's just a quadratic. Yeah, nothing too fancy about it. Then let me solve for you this guy here, the one which is let's start with this guy here, number 2, the one I skipped. So number 2, when there is no modulus symbol, first and foremost, whenever there are inequalities, please know that you cannot cross multiply. So 2x minus 1, then over x plus 2 is greater than or equal to, there's a 1 there, so there's a 1. You cannot cross multiply, so you have to take the 1 on the other side. All the time, you take everything on the right, you take it to the other side. We cannot cross multiply when it's an inequality that you have. This will be that. Then this can just become 2x minus 1, then minus x plus 2, then over x plus 2. This is 2 greater than or equal to 0. Then this is going to be 2x minus 1 minus x minus 2. Then this is x plus 2 greater than or equal to 0. Are you okay up to this stage?
Yes, I'm okay up to this stage.
Okay, then the top part, we can gather the like terms. We can just have x, then minus 3, then down you have x plus 2. This whole thing must be greater than or equal to 0. So when you reach at this point where you cannot simplify the denominator or the numerator, we solve the numerator, whether it's a quadratic or what, we solve it. So we solve this, it gives us x is equal to 3. We solve the bottom part. Also, even if it's a quadratic, solve it and get your 2 answers. So we have gotten, we have a negative 2 and we have a 3. So once you get these 2 answers, you have to test it. If you choose a number this side, let's say negative 3. If you put negative 3 here on top, it's going to be negative 6. Down is going to be negative 1. This answer that you get is 6. Is 6 greater than or equal to 0? It's true, right?
Yes.
So once it's true, we expect this side to be false, but it's not a guarantee, so we have to check. If we put a 0 there, it will be negative 3 over 2. This is less than 0, it's not greater than, so no wonder it's false. Pick anything bigger. That's going to be positive, that's going to be positive, that's going to be what, a 6. This is greater than 0, so this is true. So meaning our solution set is going to be x is such, it's from negative infinity up to negative 2, then they said greater than or equal to, so the thing here will be closed, because meaning 2 is part of the answer, then union closed 3 up to positive infinity. This is going to be the answer that you get.
Yes.
Is this okay?
Yes, it is okay.
Yes, so this is how you handle, the same way that I've done this guy is how you do this guy. You take this on the other side. So meaning we've done this, we've done that, these should be okay. Now, the ones that have modulus expressions like these that you have, we can do this in 2 ways. So I'll just show you the easier way that we can do them. So if it's a less than, like this guy here, when they say it's a less than, they're saying when it's a less than, so it's like, let me give you this. If I give you this is less than a, this means negative a is less than x and x is less than a. So now you can break it down to say negative a is less than x, or you can say x is less than a. From here, right, you can take this or you can take this, isn't it?
Yes.
So it's a similar way. If they give you something like what they've given us here, they have given us x minus 4, then over x, they're telling us, so this thing is less than or equal to 3. So we'll take it as positive to be less than 3. Then again, we're going to take it as a negative. So we'll say this is that over x. This is going to be greater than or equal to 3. So we'll solve this part. When you solve it, the same way that we solved these ones.
So can you just choose any how the inequality will be, since you're saying for x minus 4 over x is less than or equal to 3, and then negative x minus 4 over x is greater than or equal to 3. Is it that it always choose that the negative side is greater or equal to, or you can just choose yourself?
Oh no, it's dependent on what they have. They're telling us that this guy, modulus means it's positive. So they're telling us to say, if this thing is positive, it means it's going to be less than or equal to 3. This is the first case.
Okay.
Then the second case, now you create it. You're saying, meaning if this thing is negative, it will be greater than what? Or equal to 3.
Yes.
So that's what we have. Then once you create this, you take the 3 on the other side. The same way we did this one, the same way we solved this one is how you solve this. So let me just solve it for us here. There's x minus 4 over x. We've said it's less than or equal to 3. So when you take the 3 this side, this is less than or equal to 0. This is going to be x minus 4 minus 3x. This is x is less than or equal to 0. This is going to be negative 2x, then minus 4 over x is less than or equal to 0. So with the down part, when you solve it, it will give us what? This is going to give us, okay, the down part is going to give us a 0 when you solve it. But we know to say 0 is not, when we put 0 here on top, we cannot have x is equal to 0, because x is not part of the 0 is not part of the domain of this expression, because when you put 0 in the denominator, it becomes undefined, right? Are you seeing this, Nimezi?
Yes, I'm seeing.
The numerator, when we solve it, it's 0. So 0 is not part of the domain. The only thing that will allow is negative 2x minus 4 to be equal to 0. Negative 2x is equal to 4. Divide here, divide there, meaning x is equal to negative 2. That's what you have. So the negative 2 that we've gotten, we're going to test now. You test which side is this whole thing going to be less than or equal to what? 0. So you're having when you put negative 3, put negative 3 there, that's going to be a 6, then minus 4, down there's a negative 3, this is a 2, but there's a negative 3. This is less than or equal to 0, so it's true this side, meaning it will be false the other side. So meaning the answer is, the first part that we have is negative infinity to negative 2, and it's closed because they said less than or equal to. So this is going to be the first part of the answer.
Yes.
The second part of the answer will come when you solve this guy. When you solve this, you get the same thing. So you can just multiply with a negative. This is going to be negative x plus 4. Then down you have x is greater than or equal to what? 3. Then take the 3 this side. You solve it. When you get that answer, you unionize it with the answer we're from getting. So it's going to be union this answer that you have. So that is going to be the final solution for the whole question. That's how you simply do it. Because here we'll just take the 3 this side. It will be, let me erase the side to just try to solve it here. So it's going to be negative x plus 4 over x, then minus a 3 should be greater than or equal to a 0. Then down, we're simply having x. This is minus x plus 4, then minus 3x, so greater than or equal to what? A 0. Then from here, you simply solve the top part. This is going to be negative 4x, then plus 4, then down there's an x greater than or equal to 0. Of course, you cannot take the denominator because it's not part of the domain, so the only part we solve is the top part. So x is equal to 1. We check. Which side of 1 do we allow? We have a 0. If I put a 0 there, it's not allowed. If I put negative 1 there, that's going to give us 4. So you're going to have 8 over negative 1. That's not greater than 0. So this side it's false. Then this side it will be true. So meaning it's 1 to positive infinite. Yeah, so we come back to this guy, we say union. We're saying 1 to positive infinite. This is going to be the solution set where x can be satisfied for this inequality.
Yes.
Is this okay?
Yes, it is okay.
So that's what you get. So it's the same thing that you do for these others as well. Same thing that we've done here. You say this is greater than 3 or negative of this is less than 3. You solve the two things separately, then unionize the solution sets. Yeah, same applies with this. You just do it the same. Same applies with this. It's the same thing.
Since these other ones have like the denominator can be x plus 4, do I use the denominator or the numerator to find the domain? I use the denominator?
We use them both.
Okay.
Yes, we need to find a solution set like this guy here that you have. Like here, a perfect illustration is here. You solve the top part, you get x is equal to half. The down part gives you x is equal to what? 1 over 3. So you test between 1 over 3 and 1 over 2.
Okay.
Yeah, so that's basically what you have. Is this okay?
Okay, now I understand how to solve them.
Okay, so I heard that there's a tutorial sheet 5 as well.
I haven't yet received it.
Okay, just try these ones that I said they are similar to the ones we've done. Then you send me the solutions for confirmation's sake. Yeah, then are you done with Newton's laws, or you're still in physics? What topic are you doing?
I didn't go for the last class, but I was told that we're going to finish it tomorrow.
Oh, okay. Then what are they starting? Are they starting what? Work, energy, and power now?
Yes, that's what we're going to start.
Oh, okay. All right, then we'll have our class tomorrow. You let me know what you want to learn tomorrow.
Okay, tomorrow from 11 to 19.